Welcome to MRL. In this learning session, we'll be learning about algebraic identities. Before we begin learning about identities, let us understand as to what is an algebraic equation. An equation of algebraic expressions is an algebraic equation. An algebraic equation is true for a particular value of a variable. It means a particular value of variables satisfies the equation or makes LHS is equal to RHS. Let us understand this with an example. This is algebraic equation. It's a linear equation in two variables, x plus y equal to 7. Now if I put x is equal to 3 and y is equal to 4, then 3 plus 4 is equal to 7, 7 is equal to 7, LHS is equal to RHS. Therefore, particular value of x is equal to 3 and y equal to 4 satisfies this equation or makes LHS is equal to RHS. Therefore, x is equal to 3, y is equal to 4 are the only solutions which satisfy this equation. Let us take one more example. X plus 2 equal to 5 is a linear equation in one variable. If I put x is equal to 3, then 3 plus 2 equal to 5, 5 is equal to 5, LHS is equal to RHS. It means that value of x is equal to 3 is the only value which satisfies this equation. Therefore, particular values of x and y satisfy the equation or make LHS is equal to RHS, and that is what we see in algebraic equation. Now let us understand as to what is an algebraic identity. An algebraic identity is also an algebraic equation. Please understand this. An algebraic identity is also an algebraic equation which is true for any value of the variables. It means an identity is satisfied by any value of the variables. Let us take one example here. Now if you see here, a plus b square, a plus b whole raised to square is equal to a square plus 2ab plus b square. There is LHS, there is RHS, there is equal to sign. It means it is 100% an algebraic equation. Of course, it is an algebraic equation of second degree. Now if I put any value to a and b, if I put a as 1 and b as 1 and substitute on the RHS, we find that LHS is equal to RHS. Put different values of a and b, we find that LHS is equal to RHS. That means this equation, which is an algebraic equation, is satisfied by any value of the variable, and therefore it is called as an identity. So the difference between an algebraic equation and algebraic identity is an algebraic equation is satisfied by a particular value of variables, whereas an algebraic identity is satisfied for any value of the variables. Remember that. Now we have different important algebraic identities. A few of them I have listed here. There are only 14 of them. Very important identities. Try to remember these identities. Very useful in applications in mathematics. Now the first identity is x plus a into x plus b is x square plus a plus b into x plus ab. A plus b whole raised to square is a square plus 2b plus b square. A minus b whole raised to square is a square minus 2b plus b square. A square minus b square is equal to a plus b into a minus b. A plus b plus c whole raised to square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. A plus b whole raised to cube is equal to a cube plus 3a square b plus 3ab square plus b cube. A minus b whole raised to cube is equal to a cube minus 3a square b plus 3ab square minus b cube. A cube plus b whole raised to cube is equal to a plus b in the bracket a square minus ab plus b square, and this is factorization here. A cube minus b cube is equal to a minus b in the bracket a square plus ab plus b square. A cube plus b cube plus c cube minus 3abc is equal to in the bracket a plus b plus c, and again in the bracket a square plus b square plus c square minus ab minus bc minus ca. Very important identity. Now if you take three factors here, x plus a into x plus b into x plus c, there are three binomials product of three binomials, then we get x cube plus a plus b plus c, x square plus ab plus bc plus ca into x plus abc. A very important identity again. A cube plus b cube is equal to a plus b whole raised to cube minus 3ab in the bracket a plus b. A cube minus b cube is equal to a minus b whole raised to cube plus 3ab in the bracket a minus b, and a cube plus b cube plus c cube is equal to 0 under given condition that a plus b plus c equal to 0. So these are various important identities and very useful in mathematics, in every branch of mathematics. Remember that. And remember, to prove them, it's a very simple thing. Take the product of this, applying distributive property, we get RHS. Take the product of a plus b into a plus b, we get RHS. So therefore, the identities can be proved very easily by simplifying LHS and getting RHS. Let us take one example here. A plus b whole raised to square is equal to a square plus 2ab plus b square. If I have to prove this, then take LHS, that is a plus b whole raised to square. Then a plus b whole raised to square is nothing but product of a plus b into a plus b. Now apply distributive property. A in the bracket a plus b plus b in the bracket a plus b, we get a square plus ab plus b square, a square plus 2ab plus b square, which is equal to RHS, and that is how we can prove the identity. Similarly, all the identities also can be proved. Remember that. Now let us learn a few examples of application of identities. If I want to find the product of 102 into 103, I can directly go for product method, but here I want to apply algebraic identity. So let us see which identity can be applied. Now 102 can be written as 100 plus 2, 103 can be written as 100 plus 3. If you observe, the first term is same, second term and second term of both are different. Therefore the identity which can be used is x plus into x plus b. X plus into x plus b is x square plus a plus b x plus ab. Here x is 100, a is 2 and b is 3. Now substituting these values on the RHS, we get 100 square plus 2 plus 3 into 100 plus 2 into 3, that becomes 10,000 plus 500 plus 6, and that is 10,506 is the product of 102 into 103. That is how an identity can be used. Similarly, let us take one example, 99 whole raised to square. 99 square, take the product of 99 into 99, will get the product. But here we can apply the identity. 99 can be written as 100 minus 1 whole raised to square, and that is a minus b whole raised to square. A minus b whole raised to square is a square minus 2b plus b square, and identity here a is 100 and b is 1. Put the values on the RHS, we get 100 square minus 2 into 100 into 1 plus 1 square, that is 10,000 minus 200 plus 1, 9,800 plus 1, that is 9,801, and that is how we find out the product of 99 square using the identity. Let us take one more example, 103 into 102 into 98. So this is the product of 3 factors. So now if you want you can multiply directly by taking the product of the first two and again multiplying with the third to get the total product as 1029588. Instead of that, we can go for using an identity. And the unique thing is, now 103 is 100 plus 3, 102 is 100 plus 2, 98 is 100 minus 2. The first term is the same, 100, 100, 100, so that means it is x. And the second term is here we have 3, 2 and minus 2. So we can use identity x plus a into x plus b into x plus c. X plus a into x plus b into x plus c is x cube plus a plus b plus x square plus ab plus bc plus ca into x plus abc. Here x is 100, a is 3, b is 2 and c is minus 2. Substitute in the RHS and get the value. So 100 cube becomes 1 followed by 6 zeros, and here 2 and 2 will cancel, we get 3. 100 square is 10,000, and 6 and 6 minus 6 will cancel, minus 4, minus 400 and minus 12. Now add this, that is we get 1029588. So that is how we can use the identity for finding out the product of numbers. So please remember that. In this learning session, we will be learning a very important operation in algebra, and that is factorization. Now factorization is a process of expressing a number as a product of numbers. Factorization is a process of expressing an algebraic expression as a product of 2 or more algebraic expressions. So please remember that factorization is a process of expressing an algebraic expression as a product of 2 or more algebraic expressions. A very, very important operation. We'll be learning why. Now the methods of factorization, there are different methods of factorization, and they are taking HCF common, grouping and taking HCF common, regrouping and taking HCF common, identity method, middle term splitting method, and factors theorem method. Now let us understand it. And the identity which we are using here is x plus a into x plus b, that is x square plus a plus b x plus ab, and that is used in the splitting method. Now let us learn these methods one by one. Now the first method is the taking HCF common. Now we have the algebraic expression here, 12a square b and 15ab square. Now we have algebraic expression 12a square b and 15ab square. Now the factors which are common in these two, let us see what are the factors here. So let us take the constants first, 12 and 15. The HCF of 12 and 15 is 3. So 3 is common. Then the HCF of a square and a is a, and a is common. HCF of b and b square is b is common. Take the product of the common terms, 3 into a into b, so 3ab is the HCF of both. So take 3ab outside and remaining terms you put in the bracket. Now if you multiply 3ab into 4a, 3 into 4 is 12, a into a is a square and b, then multiply 3ab into 5b, we get 3 into 5 is 15, a is a and b into b square, and therefore it is 100% a correct factorization. Now here we had an algebraic expression, and we have expressed it as a product of 2 algebraic expressions, that is 3ab and 4a plus 5b, and that is what is called as factorization. And the method adopted here is the taking HCF common. Remember that. Now let us take one more example. Now we want to factorize this. that is 20 L square M plus 30 ALM. So first find the HCF of 20 and 30, it is 10. Okay, it is 10. Find the HCF of L square and L square and L is L, and HCF of M and M is M, and therefore the product is 10 LM. Take 10 LM outside and the remaining factors put it in the bracket here. Now let us see, it is 10 LM in the bracket 2L plus 3A. So 10 LM into 2L, 10 into 2 is 20, L into L is L square and M as it is. Then 10 into 3 is 30, L A is 3A is here, LM, and therefore we have expressed this expression as a product of two expressions, and that is a factorization by taking HCF common. So in factorization by taking HCF common, take tel LM outside, and which are common to both the algebraic terms here, and the remaining terms we put in the bracket. So that is the method. Now the second method of factorization is grouping and taking HCF common. Now we have four terms here. Earlier we had two terms, here we have four terms. When we have four terms, then we can group them and take HCF common. Now let us group them first. X square plus xy and 8x plus 8y. And the grouping is done by inspection, so that we get HCF common to the two terms here and the two terms here. So now in the common, that is HCF of x square plus xy is x, because x square is there, x is there. So we can take x outside. So x into x is x square, x plus into plus is plus, x into y is xy. So x is outside, and in the bracket we get x plus y. So we have expressed as a product of two algebraic expressions here. And now here also take 8 common, x plus y. Now in these two, what is common? X plus y is common. So take x plus y outside and put x plus 8 in the bracket. So the method is first group them, pair them, and then take HCF common, and again take HCF common. That means two times we are taking HCF common. Again, remember, ultimately the important step is taking HCF common, and that is two times, here and here. Now therefore, grouping and taking HCF common is again another method which we have understood here. Now regrouping and taking HCF common. Now here we have an algebraic expression given to us, 6xy minus 4y plus 6 minus 9x. Now by inspection we understand that we have to be regrouped. Therefore I have kept 6xy here as it is, minus 4y as it is, but here I have interchanged the position. I have taken minus 9x and I have put plus 6 in the last. Now what you call pair them. So if you pair 6xy minus 4y and minus 9x plus 6, in this the HCF of 6 and 4 is 2, the HCF of x is xy and y is y, and remaining 3x minus 2 in the bracket. Multiply it and check. 2 into 3 is 6, x into y is xy, plus into minus is minus, 2 into 2 is 4y. Now in this 3 is common, that is the HCF of 9 and 6 is 3, take 3 outside and remaining you put in the bracket. Minus into plus is minus, 3 into 3 is 9x, minus into minus is plus, and 3 into 2 is 6. Remember, when we factorize, when we multiply, we should get back the previous step. Then only our method of factorization is correct. Now again take HCF here, so 3x minus 2 is common, take 3x minus 2 outside and 2y minus 3 in the bracket, and that is what is the factorization of the given algebraic expression. We have expressed it as the product of two algebraic expressions here. So the method is very simple. First try grouping it, but if you fail to group it to get factorization done, then regroup it, take HCF common, again take HCF common. So these are the four steps which we have to follow in this method. Now the next important method is the identity method. Now let us consider an example here. Say the word that it's very clear we have to use an identity here. We have got the example here is x square minus 81. X square minus 81 can be written as x square minus 9 square. And you know that it is a square minus b square. We have an identity, a square minus b square is a plus b into a minus b, where a is x and b is 9. So we have got a square minus b square, that is x square minus 9 square, and apply the right side. So it will be x plus a and x minus b. X is x, and that is a is x here and b is 9. Therefore x plus 9 into x plus x minus 9, x plus 9 into x minus 9. So that is what is the identity method. Now let us take one more example. Now we have got an algebraic expression of three terms here, 4x square plus 20xy plus 25y square. Now by inspection we see that the first term is the square term, 4x square becomes 2x whole raised to square, 25y square is 5y whole raised to square. That means first term and the last term are square terms. So we have to check whether we can apply the identity here. The identity which can be applied is a square and b square is there. So a square b square is there, and the middle term is 2ab. If I use this identity, then I will get a plus b whole raised to square. But now we have to confirm whether the middle term is possible here. Now we know that 2x is the first term, 5y is the second, next is the last term. When I multiply 2x and 5y with 2, it will be 2 into 2x into 5y, that is 2 into 4, 4 into 5 is 20xy. 100% we get the middle term, therefore I can use this identity. Now let us rearrange these terms here. 4x square is 2x square, 20xy is 2 into 2x 5y, 25 square is 5y square. So it is a square plus 2ab plus b square form. Now I can apply this identity, take a plus b, a is 2x, b is 5y, therefore it is 2x plus 5y whole raised to square, and therefore the factorization is 2x plus 5y into 2x plus 5y. Again we have expressed the given algebraic expression as the product of two algebraic expression, and here we have used the identity a square plus 2ab plus b square is equal to a plus b whole raised to square. Remember that. Now one more example, 27x cube minus 216x square plus 576x minus 512. Now looks very difficult here, but see, this is the cube term. 27x cube is 3x cube, 512 is 8 cube. So we have two cubes here, terms here, first and the last. Now if two cube terms are there, we can definitely apply one of the identities, that is a cube minus 3a square plus 3ab square minus b cube is a minus b whole raised to cube. Now we have to check whether the middle two terms can be obtained there correctly. If the middle terms are exactly the way it is, then we can use this identity. So let us understand. 27x cube is 3x whole raised to cube minus and this is minus 8 cube, then this is minus 3a square b. A is 3x square into b is 8, and 3ab square plus 3a is 3x and b is 8 square. Now multiply, minus 3 into 3 is minus 9, into 8 is minus 216, and therefore it is 100%. So 3 square is 9, 9 into 3 27, 27 into 8 is 216, and that is correct, and x square, that means we got the term. Now same way you can check here, 3 into 3 is 9, 8 square is 64, 64 into 9 is 576 into x, and the next term is 512 as it is 8 cube. That means it is exactly this identity. Now therefore RHS is a minus b whole raised to cube. Use this. Therefore here we have a as 3x and b is equal to 8. Therefore a minus b whole raised to cube becomes 3x minus 8 whole raised to cube, and 3x minus 8 whole raised to cube is 3x minus 8, 3x minus 8 and 3x minus 8, and that is what is the factorization. So we have three important factors here, because it is third degree algebraic expression or polynomial. So therefore remember, if it is second degree we have two factors, if it is third degree we have three factors. Now the next important method is the middle term splitting method of factorization. Now let us understand this, and as I have told you, in middle term splitting method we use an identity x plus a into x plus b is equal to x square plus a plus b into x plus ab. Let us see how it is used. Now this is the example given here, x square plus 15x plus 50. Now there are only three terms here, so therefore whenever there are three terms we have to go for middle term splitting. So 15x is the middle term, we have to split it and make four terms, but there is a procedure of splitting, and the procedure is very simple. Check the coefficient of x square first, it is 1. Multiply the constant is 50. Multiply the coefficient of x square and the constant, that is 1 into 50 is 50. Now find two numbers a and b, so that the multiplication, when you multiply you get 50, and when you add you get 15, and the two numbers are 10 into 5 is 50, 10 plus 5 is 15. So therefore we can split it in the form x square plus 10x plus 5x plus 50. Now we have got four terms here, and when four terms are there we can very well go for grouping and taking HCF common. So now group it. So first pair is grouped, second pair is grouped. Now the HCF between x square plus 10x is x. Take x outside, x into x is x square, and x into 10 is 10x. Therefore in the bracket we get x plus 10. Here 5 is common, take 5 outside, 5 into x, therefore x will come here. 5 into 10 is 50, 10 will come in the bracket. So we have got x in the bracket, x plus 10 plus 5 in the bracket, x plus 10. Now x plus 10 is common, take x plus 10 outside and put in the bracket x plus 5. So that is the method of what we call the middle term splitting method. So please remember this method, practice it and learn. Okay, now let us go for one more example. 3x square minus 10x plus 8. This is a algebraic expression here. Now we have three terms here. Now we have to go for middle term splitting method. Now the method is, what is the coefficient of x square here? 3. What is the constant here? Plus 8. So 8 into 3 is 24. We have got 24. Now find two numbers a and b. When we multiply we get 24, and when we add we get the middle term, that is coefficient, that is minus 10. And the numbers are a is equal to minus x, b is equal to minus 4, because minus 6 into minus 4 becomes 24, minus 6, and when we add to minus 4 it becomes minus 10. Therefore split it such so that we can split in the middle term as 3x square minus 6x minus 4x plus 8. Now please remember, minus 6 minus 4 is minus 10, minus into minus is plus, and 6 into 4 is 24, because 8 into 3 is 24, and we have now 4 terms here. Now go for grouping and taking HCF common. So group the first two terms and the last two terms. Now take the common thing here. 3x is common, because 3x into x is 3x square, minus as it is 3x into 2 becomes 6x, and this is the correct taking common. Now minus 4x plus 8, what is common here? 4. Take 4 outside and put x in the bracket, and then minus 2 in the bracket. So minus 4 into x becomes minus 4x, minus into minus is plus, and 4 into 2 is 8. And now take common here. The common is x minus 2. Take x minus 2 common and put 3x minus 4 in the bracket, and that is what is the method of middle term, middle term splitting method. Now the important procedure is grouping and taking. So again you see here, although it is a middle term splitting method, again we end with grouping and taking HCF common, or taking HCF common, which is the basics of factorization of algebraic expressions. Now there are different applications of what you call the factorization. So let us see how we can use it. Now this is here we have an example where we have to simplify. It looks so difficult first. That is 116 into 116 into 116 plus 34 into 34 into 34 divided by 116 into 116 minus 116 into 34 plus 34 into 34. Looks very, very difficult. So now let us make it so it is simple. The calculations are going to be very easy if we apply the identities and factorization method. Now let us take 116 as a and 34 as b. Now replace 116 here, it becomes a cube, and this becomes b cube, and here it becomes a square minus ab plus b square, a square minus ab plus b square. We know that the identity we have a cube plus b cube, and a cube plus b cube identity is a plus b in the bracket, a square minus ab plus b square, and a square minus ab plus b square. You see, a square minus ab plus b square and a square minus ab plus b square will cancel, and what we get is a plus b. And what is a? 116, and what is b? 34. Put the values, add it, we get 150. So therefore simplification of such a huge number, huge fraction of different numbers made it is so very simple now, and we get the answer as 150. Otherwise multiplying these three and then multiplying all the other values, what you call simplification, would have been a very tedious task. Now here it has become simple by using factorization and identities. So that is how we can use the identities and factorization in calculations.